All right, this is part two of the chapter 10. We want to talk a little bit about the whole concept of sample size. I tried to find some YouTube videos. I posted one on the site, the course site, about the whole concept of sampling and sample error. Um, but we need to talk about sample size. A lot of the videos and a lot of people that you'll talk to, there's like a mathematical formula to determine sample size. We're not going there. And the book doesn't go there. But you will see that if you have taken a statistics course, you know what I'm talking about. And we're not doing math, where this is not a math class, thank goodness. I'm not a math teacher. But there is a formula that you can use to determine your sample size, what it should be. Um, the biggest thing to remember about sample size is that depending upon the size of your population, that the bigger your sample size, the less your margin for error is going to be. So if you can do the whole population, if you can use the whole population in your research, you are going to have like a zero margin for error because you got everybody or everything. If you have 100 people in your as your population, and you do 50, well, that has greatly decreased your margin for error, but there's still a little bit there. There's a calculation to determine what that is. If you have a population of 1,000 and you only do 50, then you can obviously see that there's a greater chance for error. That margin of error, it's that confidence interval that we talked about. Um, And so that's why the sample size is very important. Now, if you're doing non-random sampling, like I said, I think at the end of the other video, it's not important um, because you're not making that application to the entire population because non-random sampling, you can't do that. So that is why with random sampling, sample size is important. Um, and as I said, I think I started talking on the other video that the three things that you have to consider when you're thinking about your sample size is the size of the population that you are looking at, or as the author calls it, the population of interest. And so that is who you are looking at. The second factor is how accurate do you want your results to be? Meaning that's your confidence level. And in social sciences, the confidence level is usually 95%. That means that if you have 100 people and that 95 of them are going to have the same results that your study came out with, and that the 5 may not. So they want to make sure it's not going to be 100%, but in social sciences, the acceptable that acceptable confidence level, I'm making sure I get the terms right, is 95%. If you take it down to 90%, there's a 10% chance that you are wrong. So the confidence level basically indicates how sure are you that your information can be applied to the entire population. And I'm looking at page 157 in your book. There's some good information there that kind of describes these things much better. The third factor that you want to think about is it says in deciding the size of the sample is precision. How precise do you want to be? And it's also often referred to as sampling error, margin of error, or the confidence interval, not to be confused with the confidence levels. Those are two different things. The confidence level is what I just talked about, is that 95% is the confidence level. The confidence interval is precision, is how precise do we want to be. or sampling error. And I think that was the video that I put on the course site was on sampling error. So these are some of the things that you have to think about when you're looking at your sample size. Um, More is better is the best way to look at it. You can look at and find the calculation to determine your sample size, what your sample size should be. Um, your research, your precision, and your accuracy are going to be increased by a larger sample size. That is the important concept to remember. Um, let's see here. When you're thinking about too, you have to look at the characteristic of the population, or how I'm trying to think how to say this. If you're looking at a particular characteristic in that population, in that total group, um, you have to look at the proportion of that characteristic in the total group. If you want to know, like I said, if you want to get males and females, is kind of an easy way to do that. You're going to have to look at that may affect your sample size. The example they give in the book, that if researchers looked at the gender variable, they would assume there would be a 50-50 split between men and women. Well, that's not always necessarily the case, and so you may have to adjust for that. Again, sample sizes are there's a minimum, but you want to get as many as you can. And again, we may not know the size of the population, so our sample size, um, it may not, we can't really, it's a non-random when we do that, simply because we don't know what the sample size is, and it's hard for us to come up with any kind of confidence level or margin of error because we don't know what the population truly is. Um, and then the book discusses non-sampling, and I thought they talked about determining sample size and then non-sampling errors. There's different errors that can be involved. The PowerPoint goes into a lot of talking about probability and the bell-shaped curve and the normal curve. Look at that. Certainly, it's not in the book, but it is good information to know, certainly as they talk about precision and margin of error, the confidence interval. All of that information is going to be, it's important information. It like I say, it's not in the book, but at least read through the PowerPoint slides and acquaint yourself with that. Um, Non-sampling errors, these are some of those times when they can come in the forms of questions and responses. People tell you what they think you want to hear. And non-sampling errors can occur when people don't give truthful answers. If you're going to ask somebody about their drug use, I think about students at the college. I don't know if we're going to get a correct answer or not. So that can be a non-sampling error in your research. Of course, we kind of talked about that. Low response rate. And I think I mentioned in one of the other videos about one of my EFO papers had a very low response rate. And I should have just, after I've read this, that the volunteer group was not really something that was on our radar when we did the paper, but that was basically what I had, was a volunteer group, because it was not representative. It was not a good size sample. So there basically you're left with a volunteer sample. So that can be a non-sampling error. We can pick out how many, and when we talked about surveys and mail out surveys and that kind of thing, if if you have this population and you determine you needed X number of responses in your sample, you may have to send out many more to get X number, if that makes sense, because you have the return rate that you might or might not get. Make sure that you try to minimize these non-sampling errors and you just point them out in your research. And that's what I did. It's a limitation of the study is that you had a low return rate or um, you weren't sure if people were giving the truthful answers or not. So um, you do have to kind of acknowledge those in your discussion. So your sample size is something that you have to kind of think about. And look, it is dependent on your total population that you are including in your study. So if you can survey them all or look at them all or include them all, then that's a good thing to do. If you can't, the more you can, the more precise your research is going to be when you apply it. If you are using random sampling. Again, non-random, it doesn't really it doesn't really matter that much, as I understand, simply because you're not making that leap from your sample group to the total population because it is non-random, and so your sample size. Now, with that said, with non-random, you don't want to just have one. We need to have as many as we can have. But it's just a little bit it's a different when we're talking about non-random sampling. I talked in the last video about quotas, judgmental, accidental convenience, and snowball types of non-random samples. Um, and as it said, it doesn't really matter. Um, you lose that inference. It's just basically a case study when you are doing non-random. So, but you do want to make sure that you include as many as you can, but there may not be an exact number that you look at. So, I want to look at your homework a little bit, and let's just kind of run through what they're asking you to do. Um, I know I keep going back and forth, and I apologize. For each of the following situations, identify the likely data collection approach and then identify your sample, the population of interest, the type of sample, and the sampling procedure you would use. Explain your rationale. So we're going to look at the first one. There's been an increasing concern about the ability of the federal government to attract college graduates as employees. Your team has been asked to determine what image college students have about working for the Federal Civil Service. However, there's no listing of all college students, and privacy laws prohibit the college from giving out their addresses. So, if we're looking at what is our sample, our population, I guess, if we look at that, would be college students. It's kind of large. We don't know who they are. We don't have information about how to get in touch with them. And you can only imagine, are we going to, you would have to identify, are we going to do all college students or is it maybe high school or college seniors, college freshmen in a particular degree program? So, an option there is to survey the college students, but you don't have that list of students. So you can't do a random sample that way. You might be able to do a cluster sample in that you pick a college, you have a list of schools and you pick some of those schools and then you pick some of the students from those schools. You might could do it that way. If you just select some schools maybe from different regions or maybe one specific region from around the country, this would be a judgmental sample if you tried so that you could diversify to get the diversity in your responses. But then there's the challenge, of course, of getting to the students in this particular situation. You could do web-based surveys and put ads in the newspaper. But the bottom line is you're not going to do a scientifically random sample of the students because you just don't have that. As the information that I has refers to Plan B. And so sometimes you do just have to have a Plan B to handle that. doing that non-random kind of a sample. You look at different campuses from around the country, or and make sure that you're getting as close to apples and apples as you can. But the bottom line is this is going to be a non-random sample. So that's what the questions are asking. The next one, your organization's diversity task force wants you to find out the attitude of managers and frontline workers about diversity. The task force would like to conduct an attitude survey and ask you for advice about the sample. Well, depending on how big the company is, again, you may be able to use the whole population. So that's what these questions, I just wanted you to do number one. There's A through E, and I just did A for you and kind of helped you with B. So try to figure those out. And if you were going to do a study to answer these questions, what is your population of interest, as the book refers to it? What type of sampling method? Random, non-random, simple random, stratified random, non-diversified, diversified, whatever those sayings were. And also what kind of sampling procedures you would use. How are you going to determine your sample? So that's what it's asking. Um, look at, or make sure that you just kind of scroll through these PowerPoints. This is a little more complicated, but believe me, if it could be a lot more complicated because we're not doing anything with statistics. A lot of research courses do get into that whole 95% confidence level. There's 97 and a half. There's 92 and a half, I think is the way they work. But there's formulas that go along with it. Well, we're not going there, and that's one reason why I like this book. There's some. I mean, we're going to get into some of it a little bit later, but right now we're just kind of we're still in the planning phase. So if you have any questions about any of this, let me know. And again, I apologize for the lateness of getting these videos to you. I'm going to try to get back on track with getting these things done on a regular basis. Thanks for your attention. Thanks for your interest, and I appreciate each one of you. Thanks.